What is an electric motor? An electric motor can be defined as a machine used to convert the energy from electricity into motion or mechanical energy. Most of the motors work through the communication among the electrical current and magnetic field of the motor's winding for generating force in the form of shaft rotation. These motors can be triggered by a DC source or AC source. A generator is mechanically the same as an electric motor. However, works in the opposite direction by changing mechanical energy to electrical energy. The classification of electric motors can be done based on considerations like the type of power source, construction, motion output type, and application. There are AC type, DC type, brushless, brushed, etc. These motors are applicable in pumps, industrial fans, machine tools, blowers, power tools, disk drives. AC electric motors, as their name implies, are electric motors that make use of AC sources for their operation. Here we have some subdivisions. The induction motors, the synchronous motors, repulsion motors, etc. Induction motors are electric motors with slip. Slip is the difference between the rotor speed and the synchronous speed. This is explained by the relationship, slip percent equals, ns minus n divided by ns times 100. Under induction motors, we have other subdivisions like the capacitor motors. These are motors that require employment of capacitors for their operation. Here we have three divisions. 1. The capacitor start motors. 2. The split-phase capacitor motors. 3. The two-value capacitor motors. Capacitor start motors are induction motors of 1/20 to 35 horsepower in size. They operate all types of loads, from small fans to large compressors. Permanent split capacitor motor. This is a capacitor motor having the same value of capacitance for both starting and running conditions. Two-value capacitor motor. These are capacitor motors using different values of effective capacitance for the starting and running conditions. Click your subscribe button, like, and share. In synchronous motors, the presence of external excitation at the rotor eliminates the difference in speed between the rotor speed and the synchronous speed. Unlike the induction motors, synchronous motors have rotor windings and slip rings. Repulsion motors are single-phase electric motors. Here the stator windings are connected directly to AC sources while their rotor is connected to a commutator and brush assembly. DC motors convert direct current form of electricity into mechanical energy or motion. Here we have the permanent magnet DC motors, the series DC motors, the shunt DC motors, and the compound DC motors. Electric motor construction. The electric motor construction can be done using the rotor, bearings, stator, air gap, windings, commutator, etc. The rotor in an electric motor is the moving part, and the main function of this is to rotate the shaft for generating the mechanical power. Generally, the rotor includes conductors which are laid to carry currents, and communicate with the magnetic field in the stator, for synchronous motors, and then a cylindrical shaft with bearings attached to its ends for induction motors. The bearings in the motor mainly give the support to the rotor to activate its axis. The shaft of the motor expands with the help of the bearings to the load of the motor. As the load forces are used outside of the bearing, then the load is known as overhung. The stator in the motor is the inactive part of the electromagnetic circuit. It includes permanent magnets or windings. The stator can be built with different thin metal sheets which are known as laminations. These are mainly used for reducing energy losses. The air gap is the space among the stator and the rotor. The effect of the air gap mainly depends on the gap. It is the major source for the low power factor of the motor. The end plates are brackets, sometimes called end bells, bolted to the stator. The centrifugal device located on the rotor shaft. The stationary switch usually located on the end plate or stator shell inside the stator, and one or more capacitors that can be located on top, on the side, or inside the motor, in the junction box, or remote of the motor. Thanks for watching. Remember to click your subscribe button.